Hello, everybody. Somebody tried. Hi, everybody. All right. My name's Jason Farmer. I'm here to talk to you about home automation, IoT, and UWP. We've got a whole bunch of topics to cover, and we've had a lot of help hauling a lot of really heavy stuff here to show you today. So we'll get to that in a little bit, but we have a bunch of content to go through first, so let's go. First of all, a little bit of a review. The Windows Universal Platform is super important to us, and in IoT and in UWP home automation, what that means is one app, multiple devices. Inbox support for IoT standards, which is currently AllJoyn. Interoperability with a bunch of things ecosystems, and we'll talk about bridging to those things ecosystems. And rich and intelligent IoT experiences. This is where we're talking about personal experiences with your devices, and I'll talk to you a little bit about how you can do that and where we're headed. All right, so just to knock it home, UWP, if I write it on my PC or my tablet, I write it for Xbox, I write it for mobile, write it for Core, it runs on everything. And we're going to talk a little bit about IoT Core and how that plays together next. So in the last year, we had a bunch of boards we've come out here, Raspberry Pi 2, 3 just a couple weeks ago, the Intel Minnow Board Max, Dragon Board 410C from Qualcomm, all those run IoT Core. And in the course of our kind of home automation conversation we've been having with the community, we've put projects out, we've put samples out that run on all these 3 boards. Our first set of samples was a set of Hack the Home samples that tell you how to hook up things like security cameras, how to run some relays. There's a bunch of interesting stuff up on www.windowsondevices.com. And in the subsequent to releasing those samples, what we did was we launched a home automation contest. And we asked everybody to submit their home automation ideas. We had over 2,000 people submit their ideas. From that, we had 250 plus projects that were submitted to Hackster.io. It's a fantastic wealth of projects on IoT Core. It's a lot of fun to go through them. We have learned so much from those projects, and we hope that you've learned as we've produced collateral as well. We think this whole home automation space is a space where we can work with the community and feed one another as we move into the future. So let's talk about the standard stuff for a second. Today, we've got universal APIs for AllJoyn. They exist. There's some tools and templates in there around code gen. I'll talk about those in a little bit. On GitHub, we've got device system bridges. We've also got some templates for those. And then recently, we announced that we are part of the creation of the Open Connectivity Foundation. And I want to talk to you a little bit about what that means to us, what that means to the standards, and sort of how that's all moving. So, for those of you that missed all the noise I made about it last year, what is AllJoyn? The AllJoyn bus really has 2 different clients. One of them is the standard core and the router node. Those are what are in Windows right now. They can talk to any node. They're the more robust nodes, and so what you need there is a powerful operating system or a processor to run it. So you're talking Cortex-A, x86, x64. And so those router nodes will run on iOS and Android, as well as Windows, because it's a cross-plat system. The thin core is much smaller. For us, it's .NET Micro Framework. For other folks, it's other M-class devices. There's some Arduino libraries and things like that out there. But AllJoyn networks are independent of the transport layer. So you can run them on Wi-Fi, you can run them on Ethernet, Bluetooth, you can run them on other mesh IP networks. The deal is you get an app layer mesh on top of it that you can then work within. And that's the framework that we've been working on. And last year when we talked about code gen, which lets you use code to make code, you get a schema off of a device, and you're able to take that schema and produce some strongly typed UWP libraries and then write to those interfaces in your application. We said, look, you can go export the XMLs. It's kind of difficult. Here's the about interface, how you do it. And then you got to dump them and use a code gen command line tool to get the libraries prepped. And then you can go launch Visual Studio, import those libraries, and you'll be all set. But over the last year, we've made that better. Today, you basically ensure that your device is discoverable, which They all are when they've got about interfaces that they're producing. You use the VS tooling, generate the libraries that are right there. I'm going to walk you through that right now just to kind of show you how easy it is. So if we had VS stood up, or if we took a snapshot of every step we'd take, you can do project new, file new project rather. You get your all join application. You end up getting this wizard here that tells you how to find producer. I asks you to find producers on the network. What we'll do is we'll find some. These happen to be associated with this cool little speaker right here. And then you can go ahead and have them pulled into your project, which lets you write the app on top. Now, if your goal is to develop an application for a device that isn't running in AllJoin, we have a solution for that as well, using the tooling from AllJoin. So first, you need to get a device system bridge. Explain to you how those work here in a second. And then you can use the tool set that we've gone out with. So about a year ago, we open sourced this architecture called the device system bridge. And it works roughly like this. You get the network stack, you get the adapter, the bridge. In the network stack layer, we host a stack to access different types of networks. Here's Z-Wave as an example, in a UWP. At the adapter layer, we need something that manages those devices on the native network. So the adapter layer lets you basically instantiate the Z-Wave device the way the Z-Wave expects it, and then manage the credentials and pairing and whatever you need to do to make sure that that device stays up in your network. And at the bridge layer, you get the virtual all-join devices that can represent each of the other devices as a separate bus attachment, or depending on your architecture of the bridged ecosystem, you may end up collapsing various things into a virtual bus attachment. That's sort of up to you. When I had a little slide on this last year, actually, we had a little booth. We showed Z-Wave and BACnet. And we said, look, we've got a Z-Wave plug and we've got BACnet. We've come a long way this year. There's been a lot of activity. We've done some of these. Other folks in the community have done others. But now there's a Zigbee one, there's a Modbus one, there's an Inocean one, Honeywell, Econet, and a few others that aren't listed here. This has been a really, really cool opportunity to see how all these buses can come together, all these different types of ecosystems can come together and aggregate in one place and provide a common API for app developers. So if you want to find the tools for AllJoin, extensions and updates in VS, AllJoin Studio is the first tool I showed you. That's where you're able to go and find producers and CodeGen libraries. The second one is the device system bridge template. And that would let you start and build your own system bridge to your favorite ecosystem that we don't already have covered and available in GitHub today. On February 19th, the blogosphere had a bunch of new entries from a number of different partners in the IoT space. Here's just a sampling. There were a few others. Microsoft, along with partners like Samsung and Qualcomm and Intel, formed the Open Connectivity Foundation. And this foundation, we hope, to be the lighthouse for common ecosystems, common innovation, robust, interoperable standards going forward. As you can see, also UPnP contributed their assets. So there's hopefully a nexus coming together under the OCF banner of IoT standards so that we can kind of all move forward together, because per the Qualcomm headline there, fragmentation is the enemy of IoT. So Microsoft's vision for OCF and IoTivity, and to be fair, we're all kind of embarking on this early now, is that OCF being this member organization that's seeking to achieve de facto standards in the market, that's the overarching organization that will build the specifications. And then there's IoTivity, which is an open source project sponsored by the Linux Foundation that demonstrates those. And today IoTivity exists. It exists as the OIC implementation, and we will evolve into the OCF implementation. But you can see a sign there on the door that says IoTivity. We're looking to drive this in a way that it will remain compatible with the existing industry efforts. There are folks who have products in market. There are a lot of our partners that have products in market. We intend to make this a continued or a continuous evolution for those folks that are working on AllJoin today. We anticipate that as we work through the working groups and build this new organization, we'll be able to provide powerful standards-based discovery, introspection, schemas, security, bridging, a lot of the things you see today in AllJoin and also in OIC. So we're trying to bring the best of all worlds, as UPnP as well, into this evolved system. So the future, I'm hoping, will be very similar to what you have today, except for in kind of a vNext form, which is you can code gen applications, but we're not there yet. The reality is OCF is going to be a journey. It's going to take some time. We have a lot of work to do. We invite everybody to come and work with us. We have in 2016 AllJoin APIs and tools. I've shown you those. We are announcing today we're releasing an open source bridge between IoTivity and AllJoin. That'll be available up on github.com, WAC, ms-iot. That should be available there today. We will have productized bridges, we will have OCF tooling, and we will have converged support in Windows. And that's what we're working for. Now, the thing about bridges is they're only part of the story. If any of you have used the DSPs that we put out there, you will find that, sure, I've got 3 light bulbs. Happen to have 2 LifeX and a Hue here, but you could have a Z-Wave, a Zigbee, and a Hue. And sure, you can get them all their interfaces up into a common language. But the problem then is that each one of them requires you to code gen a library to that schema. And that can become tedious. We need a common language. It's an important problem to solve. And to that end, we're going to make an alpha available on 4.5 of open translators to things. Now, this release is intended to start a conversation around translators and how they'll work within the industry. The alpha version will utilize a unique device ID, and it makes the schemas in AllJoin translate. Uses or leverages JavaScript and Node.js to make that happen. We are engaging with the One IOTA schema effort. We are engaging with other initiatives across the IoT standards organizations in terms of schema development. But we believe that we will need translators for a period of time before everything natively builds in the common schemas. So it looks kind of like this. Each of these devices will come in. They'll still end up bridged. We'll have the open translators to things layer. It'll identify the device. Ideally, when it comes in dynamically, it'll say, oh, I know how to make that thing talk to LAMP class. I'll go grab that schema translation from the web, from the internet, inject it, and now everybody is LAMP class. You'll be able to contribute those translations. There'll be ways to pick the best translations. There'll be ways to automatically use those translations. Lots of stuff on the roadmap, but all that's coming. And this is the beginning of a journey as well. We envision the translators to be portable, to work on devices, on IoT gateways, on the cloud. And we're really excited about what's going to be possible in this space. And John Pulley's here somewhere, and he's been driving this effort. There he is. If you want to learn more about translators, look him up. All right. Now, earlier today, there was a lot of conversation in the sessions and in the keynotes around personalization, more personal computing, language as the new application level. We wanted to make some of that available to you guys as you work with us on building stuff in the IoT space. So I'm going to walk you through our vision for how that kind of plays with all this stuff on the table. First of all, when the public preview is available, you'll be able to get in and sign up, get started. I want to make things, apps, link to insights that Cortana can trigger. As an application developer, you say, all right, I want to create a new action. I go in, and there's a few that I can pick by default. Order food, send a message. Actually, we're going to do our own, thanks very much. It's going to be welcome home. We'll add it into our list. This is our list. And then we'll say, when you have an application that you want to have a deep link into, or when this insight triggers, I should say, you want to deeply link into my application. And so you'll put your link in here that deeply links into your application. Now the next step is that's all living up there in the cloud and a part of Cortana. Your users will come along and they'll get an insight one day after having installed your app. And the insight will say, oh, arriving home, by the way, would you want to tie your smart home to that? Activate smart home is the offer. If you click on that, you'll get, as a user, another prompt that says, hey, every time when you're arriving home, would you like me to activate your smart home? You can say yes, and then it'll happen every time. We did the click-through on this. We would invite folks to use this as we show you an application that we've developed that will work with this. And we hope that as the public preview comes online, we can all have a lot of fun tying this together. All right, it's time. Let's try to light up all this stuff. All right, so first of all, it's a lot of stuff, and it's all talking different languages. I want to go through each of the things, talk about how it's connecting, where it's coming from. But let me give you the overview of the slide first. IoT Core, Windows 10 IoT Core All Join Hub is in dark blue. Everything that's in the dark blue box could talk to the IoT Core All Join Hub. The Intel Puma gateway, which is right here, is in light blue. Everything that's in the light blue box, and also the dark blue box, could talk to the Puma gateway or the IoT Core All Join Hub. The August lock right now only connects to the Puma gateway. The key here is that everything in IoT should talk to each other. We didn't want to give you a precise architecture of how this is all working, but we wanted to give you an idea of how things can connect because we think this is sort of where it's going, multi-hub, multi-connect. So let's talk about the devices. On the far end, we've got a Panasonic speaker. It's right here. The Panasonic speaker is on the market. It's an all-join device. We've got an LG. It's a prototype right now. Air handler right down here that talks all-join as well. I've got a Z-Wave plug right here. And if we're super lucky, we'll be able to make popcorn with that when I push the button. I've got, and I should go back and say the LG guys were great providing us with the prototype device here to bring along. I've got an Enotion switch. The Enotion folks built a DSP to their devices. If you're not familiar with Enotion, this is neat stuff. Nothing takes a battery. They have water sensors that have cork that expands, and the kinetic energy causes it to power and fire a signal. In this switch, when I push the button, it's kinetic energy that powers the device. Their devices are then exposed into all-join, and we can use them. The Lyric folks, right here, Honeywell Lyric, they've worked with both of us. There's a DSP into all-join. There's a connection into Puma. They've been super gracious in giving us the source to make that work on their REST interfaces. And then in REST, we can pull it down locally, approximately for all-join if we need to. A Zigbee bulb can talk either via a bridge directly to Zigbee, or you can use their hub and go through the cloud. The LifeX folks, same way. You can either talk to it through the cloud or through Allseen. We have this awesome TV. It's here from Samsung. It has IoTivity running on it. So it's got a pre-release version of IoTivity running. We're able to use our IoTivity bridge that we're open sourcing to make this thing do stuff. And then the August lock, which is on our door. Some of you can see. Uh-oh, don't get too close. There we go, door. Try not to get close. There we go. All right, so that's the demo setup. Let me bring things up here and show you how it all works. So first thing I'm going to do, maybe I'm going to do it, is this is All Join Explorer. It lets you see devices on the network, show you that everything is available into All Join here, including control of the Puma gateway, which is one of these cool little devices that lets you do other things on their system. All right, then I'm going to bring up our application and scoot it over here for you all to see. Now in the application, we've represented a bunch of the different devices there. You can kind of see how they work. Down in the bottom, we have saved actions. And the theory here, our hope, is when the public preview is available for Cortana extensibility, those will be the things you deeply link. So now comes the moment of truth. Did the thing that worked in the hotel room and we rolled across the street to Moscone and plugged into the giant network here still work? I don't know, but we're going to find out. So if it does, I'll click the button here, and a lot of stuff's going to happen. I think I hear popcorn popping. Yeah? I got some cows on the TV. I got a speaker playing. I got the temperature changed on the lyric. I got some bulbs on because we're having a lighted party. Worked. Now if we're lucky, the Enocean switch will turn off a light for me. Oh, maybe not lucky. Try the other switch. Oh, let's see what happens when you go for bust. Oh, maybe not. Well, we did pretty good. A lot of stuff turned on. Thank you. The interesting thing about this whole experiment is that all these DSPs had been written out in the world. We hadn't actually shoved them all on one MinnoBoard Max until about a week ago, and we only built that application in a couple of days. The MinnoBoard's right here. So it was a lot of fun to put it all together, and we're going to keep evolving it. Right now it's available, the app itself, open source. So if you want to go help me debug why the Enocean thing doesn't work, join me online. It's really cool, though, when it does work. I'm sorry it didn't. All right, next step. Oh, something's interesting in my projector. Projector people. Let me see. There we go. Let's try again. All right, I'm going to leave the room. We're going to shut some stuff off if we're lucky. Shut her down. I smell popcorn. Is it made? Have we got it? No popcorn yet? I can smell it. All right. All right. Well, we'll wrap this up. If you want to stick around for popcorn. If you want to learn more about IoT, please, please, please visit these sessions. One is Brett Benson over there tomorrow. Maker to Market with Dan the day after. There's coding labs. They're awesome. There's coding challenges. They're awesome. And if you get a chance when you go home, see what Lily did. She's got a really cool recorded session on assigned access. What I'm hoping you took away with us today is, one, we love what you've built. Those 250 projects are awesome. Please keep building with us. We're learning so much. We hope you're learning too. There's the new DSP. There's the My Living Room app. There's Cortana extensibility. Let's hook it up and make it work together. Continue to code apps with AllJoin with confidence. We're going to keep releasing code there. We've got more work to do. We're not done. We want you to build things with AllJoin and the bridged ecosystems. We'd love for you to contribute to OCF for the future, because that's kind of the future location. And we want to contribute open translators to things and continue to help us on the schema efforts. Thank you all so much. Appreciate it.